Welcome, physics, to another episode of Physics with Dan. Today we're doing Exploring Gauge 3. We're talking about electromagnetic induction. And some various other things. So what we're doing today is we're looking at the idea of electromagnets in reverse. So yesterday we were looking into electromagnets, and we were using the idea of sending a current through some wire to create a magnetic field. However, one of the things we can do, which generators and motors do really well, is they do the reverse, where they use a changing magnetic field to create a current in a wire. And that's through a process called electromagnetic induction, which is the process of creating a current in a circuit by a changing magnetic field. And one of the ways you can do this is by taking, say, a coil of wire, of copper wire, and if you had it hooked up to an ammeter, so say we had a little multimeter right here, which unfortunately we didn't get to play with a whole bunch. There's a little circle, and then here's the screen. We connect its two leads up to basically PVC with some wire wrapped around it, and we'd connect it, and we'd see like, oh wow, look, there's current as we shove a magnet down through it. So we'd shove a magnet back and forth, or you'd drop a magnet through it, and you'd see, oh my god, look, charge is created. We've created a current flowing through this. And so that's basically what we're reading about today. There would be a lab, but there isn't too much of an ability to actually do it right now. So this is what we're working on today, inducing current. First thing, we're investigating electromagnets. There's this hands-on lab that you're not going to do or answer the questions because, most likely at home you do not have the materials to do it. However, if you happen to have some magnet wire, something like PVC pipe, and a multimeter, you actually could do this experiment at home, where you pass a magnet like such back and forth through here, and you'll see it sort of generate some current. So we're not going to really look at that, but one of the big things that you would sort of find from that is the number of coils that you have on your circuit greatly influences the amount of current that's created. So if you have more coils, you end up with more current as you change your magnetic field, compared to when you have less coils. And it's a really sort of big thing, used a lot in electric motors, and various other things. You basically you spin the magnet to create current, where if you wanted to make it into a motor, you would put current in, which would cause the magnet to spin. And it would sort of launch it into a nice little motor. And all of this sort of follows what's called the right-hand rule. So the right-hand rule, it's a little bit tricky. Basically what you do is you take your finger, so your index finger, say you have a coil of wire, so like the coil of wire for this, or not a coil of wire, for like a wire, we have the current going straight down, and then what we do is we would then point the, well, crud, wires doesn't really work too well. Basically, modified version, you put your thumb in the direction of the current, so in this case the current's up, and then you would curl your fingers around to sort of show the direction of the magnetic field lines. So when the current's going up, you do finger like curl around, similar to when we had the electric fields and we were using the right hand rule. And so if the current's going up, the magnetic field goes counterclockwise. If the current was going down, it would then go clockwise, which is kind of an interesting phenomenon. And you can actually sort of see that with some things. And yeah, we use all of this electromagnetic induction and various things quite often. Stuff like, say, your cell phone. receives its signals through electromagnetic induction. And it's sort of how we do a lot of our wireless technology, is using these principles of electromagnetic induction at sort of a larger distance, using higher and higher frequency of communication. So that is everything for today. There isn't a whole lot of questions you have to answer. However, in the Jupiter, the exit ticket, you are going to be utilizing this. I highly suggest you turn on the field lines and you have both coils available, and so you're just going to sort of send it through and sort of notice the difference and sort of explain why it happens. And one of the things that sort of happens is you end up having a higher voltage as you pass through the larger number of coils compared to the smaller number of coils. And it's basically the idea of, when you have more coils, you have more interaction per square inch, so there's more things being affected by the change of the magnetic field compared to less coils. So like more coils means more interaction is the basic idea of the exit ticket. And that should be all you need to know for today. Next week we're going to be doing a little bit more of the same, and you're going to be writing a paper, but this is it for today. I hope you all have a good time and enjoy yourselves. So this is Dan signing off.